Hey everyone, welcome to another video on building event-driven applications with serverless technologies on AWS with .NET and Terraform. Today we're going to have a look at building a publish-subscribe pattern. Publish-subscribe allows us to really nicely decouple different parts of our application. To do this, we're going to build on top of the API that we built in our first video on how to build a synchronous serverless API using serverless technologies and Terraform. As always, if you like the content, please like and subscribe below. But now, let's get into it. So here is the code we had from our last video. We create the DynamoDB table to actually hold our product information, create the S3 bucket and our Lambda functions, and then we set up our API so that we've got both the create and the get endpoint on our API gateway. This is all the same code we had from the first video. If we have a quick look at our Lambda function code that handles that, it's pretty simple in a sense that we have an API gateway proxy request event coming in. We check to see if it's a post, if there's a body in the request, and then we send that off to a command handler to actually do the work, and then we return a gateway proxy response. So the first thing I'm going to do to start to build out this publish-subscribe architecture is that we want to keep our API as lightweight and as fast as possible for latency reasons. So as much as possible, we want to avoid doing additional work within our API to keep that latency low. And that's where a really powerful feature of DynamoDB comes in, and that's DynamoDB Streams. And what DynamoDB Streams allows you to do is to stream changes to your database out of DynamoDB and trigger maybe a Lambda function off the back of that. And when you enable a DynamoDB stream, you can choose to stream either the old images, so if it was an update, you would just get the version, new and old images, which means if there's an update, you get the new version and the older version, or just the new version. So there's 3 different options you've got though, but enabling DynamoDB Streams is as simple as just turning it on. We then go off and create a separate Lambda function to actually handle our DynamoDB stream. And what this is going to do is going to take in a DynamoDB event, and the DynamoDB stream event that you receive from DynamoDB has a set of records, and you can then loop over them records and do some work. So the first thing we want to do to check that the event type from DynamoDB is an insert. So we want to check that something's been created in our table. That's the only thing that we want to work on. And then we're going to go off and we're going to publish a event. We're going to publish a ProductCreated event to SNS. And I'll get into why I've used SNS here in just a second. From a Terraform perspective, all we then need to do is to create a mapping for our event handler. So if we go to this event handling Terraform file now, so I've just separated the code out here from my API to my event handler. And you see I've got this, I create my Lambda function, my DynamoDB stream handler, and then I create this event source mapping, this Lambda event source mapping. And what this is, I'm mapping the stream ARN from my DynamoDB table to my Lambda function. And I'm saying that this integration should always take the latest point of my DynamoDB stream. And as I said, this is going to use SNS as the publish-subscribe mechanism, that simple notification service. Now, you could equally have built this same publish-subscribe mechanism with Amazon EventBridge. And I'm going to get into EventBridge because that is used in this architecture as well. But the reason I've chose to use SNS in this location is mostly around coupling. So there are some technical differences between SNS and EventBridge. Think about the number of subscribers, the rate in which you can publish events. But outside of the technical limitations, one of the big differences I look at between SNS and EventBridge is around coupling. So when you publish an event to SNS, you couple that to a specific topic. So if I have a product created topic, an updated topic, and a deleted topic, that's 3 separate endpoints that I both need to publish to and subscribe from. So there's some quite tight coupling there in a sense that I'm coupled to a specific endpoint. Whereas when you use something like Amazon EventBridge, everything is published to a single endpoint. So there's just a publish events endpoint on the EventBridge API. So regardless if it's a product created event, updated event, or deleted event, my publishers and my subscribers all have one single place to publish and subscribe to. So the way I look at that, again, outside of the technical limitations around service limits and things, that if I'm within a domain, if I'm within a service, then I tend to use SNS because it's a lot more descriptive. I am publishing to a topic on things around products being created. If I'm doing inter-service communication, that's when EventBridge comes in. And we'll get into that as we get through this video. So let's have a look at SNS. So I'm just creating an SNS topic, nice and simple here, and all I need to provide to create an SNS topic is a name. I then add some permissions to my DynamoDB stream handling Lambda function to allow my function to be able to publish messages to SNS. And if we just go and have a look at that IAM policy nice and quickly, our SNS publish policy simply just allows SNS publish. That's all required for that to work. And that's SNS. So our API now has got the same latency as it had before. It's just writing data to DynamoDB, and that keeps the responsibilities of that API nice and simple. It's just a CRUD API to create, read, update, and delete. Off the back of them actions, we can then choose to take actions on the changes in our database, and that's what we're using to then start publish events. So after we've published the event to SNS, we now have a couple of different subscribers that we want to subscribe to. And the first is we need to do some work to update our product catalog, and that's something that can happen asynchronously. We're just storing the product data in a database, and now we want to go off and actually update the catalog. And we're going to do that with an SQS queue. So queuing is a really nice mechanism when you're building event-driven architectures, because it allows you to apply some kind of back pressure to the producers that you're consuming events from. Because we could have this invoking a Lambda function straight away, but if all of a sudden a big load of events come through our publisher, that's then going to directly affect our consumer, and we've got no way to control that. So just slotting that queue in between a producer and a consumer really helps to manage that load that's coming to your consumer. So we create an SQS queue. Again, all we need to provide to create queues is a name. And then we have a subscription. We create an SNS topic subscription. And we subscribe our product created topic that we created above, which is what we've got here. We're subscribing that to SQS, and we're subscribing that to the ARN of the queue we have just created here. One of the really important things when you're building an SNS and an SQS integration, that you need to give your you need to apply a queue policy to your SQS queue to allow SNS to be able to send messages to it. And this is really important because if you don't do this, the bug kind of gets lost. It's really hard to figure out what is happening. So you see we've got this simple IAM policy here. We're saying SQS send message to our queue resource, and that is allowed when the ARN of the source that's trying to send that message is our SNS topic. So that's a really important thing to remember, that you need to add a policy to your SQS queue. We've then got our Lambda function that's going to do the processing of our product catalog and the permissions of that now. So the second subscriber we have to our SNS topic, and this is an example of what's called the fan out pattern, where you publish to a single topic and then that fans out to lots of different consumers. So we've got our update product catalog consumer, that's one subscriber. And then we've also got a second subscriber that's going to actually publish our events externally. So this is all within our product service at the minute, but there's other services that may well be interested in these events. So I've got a second Lambda function here that's actually going to do the publishing to Amazon EventBridge. And like I said before, EventBridge is really powerful for cross-service communication. SNS is great, but there is a slightly more coupling when you're using SNS. So let's go and have a look at our external event publisher code now. So if we go and have a look in here, and then our function code. So again, we've slotted an SQS queue between our subscription to the topic and to our actual Lambda function. So you see we've got another SQS queue here called external event publishing, and we set up that same topic and that same queue policy. We then create our Lambda function for external event publishing, and we attach the policies that are required to that. If we go and have a look at the function code now, you see that the function handler is reading an SQS event. And when Lambda integrates with SQS, the Lambda service polls the queue on your behalf. So behind the scenes, the Lambda service will read from the queue, it'll pull the records, it'll push them into your Lambda function as an event. You can do the work, and then providing there's no failures within your Lambda function, the Lambda service will then delete them messages from the queue. So you see we've got a batch of records here coming from our SQS queue. We read the data from SNS, and one of the really important things to remember with this is that when you actually read the message from SQS, that will include all of the additional information that SNS adds around your original publish. So if we go and have a look at this SNS to SQS message body, so you see when this message actually hits the queue, SNS adds a wrapper around our actual message. So we've got the message ID, the topic ARN, and the message attributes. That information is added by SNS, and the content of this message property, that will be what is actually containing our event data. So if we go back to our function now, you see, so we're deserializing the contents of our SQS event to this SNS to SQS message body object, and then we read some data, and we actually then put the event to EventBridge. So when you publish an event to EventBridge in C#, the API call takes a list of events to publish, and you can publish up to 10 events in a single API call. So as I'm looping through my SQS records here, I'm incrementing a counter, and I'm checking that once my list of events equals 10, I will then actually run a publish at that point, and then create a new list to then publish the next time. Once I'm out of the for each loop of looping over my SQS records, that's when I then get down here and I actually do a final publish. I check to see if there's any events left to publish, and if there are, then I'll do a final publish just to make sure that no events are missed. And this is now publishing events out into EventBridge that other consumers can subscribe from. For the Terraform code for my Lambda function that's subscribed to SQS, I've actually abstracted some of that away into a separate module. So if we just go and have a look at that module now, we have got this Lambda for SQS sourced Lambda function option. And this is very similar to the Lambda function module we looked at last time. It all just adds this additional Lambda event source mapping. So when I actually use this module, I pass in my QARN and my queue name, and at that point I then create the Lambda event source mapping that actually maps our queue to our function. And when you do that with SQS, you can set a batch size, and that's the number of records that the Lambda service will take from SQS and pass into your function. So if I set that batch size to 10, I can then guarantee that when I get into my function code, that the actual number of records, this number of records here in my event, will never be more than 10 because I've set my batch size to 10. The other thing that gets added in here is some of the policy information. So we set the IAM policy of our Lambda function to allow our Lambda function to receive messages from the queue. So we just abstract all this complexity away into a separate module. That means when we call this, we can just call our SQS sourced Lambda function. So this is the first level of our publish subscribe. We've got this SNS topic that our consumers can publish to, our producers can publish to, and then we've got two subscriptions that are both for SQS queues. So we're subscribing an SQS queue to update our product catalog to SNS, and we're also subscribing our external event publisher that's going to transform these events into something that the wider world can understand and publish that to EventBridge. So what about subscribing from EventBridge now? So we've got subscriptions to SNS, so let's go and have a look at subscribing to EventBridge now. And to do that within this sample application repository, I've added a couple of additional services. I've added a customer service and a purchase order service. Both of these have reasons to be interested in our ProductCreated event. The purchase order service so that it can go off and purchase some stock, and the customer service to maybe send notifications to our customers to say, if you're interested in this type of product, we've got this new product and you want to go and look at it. So if we have a look at the purchase order service, because the code for both of these services is quite similar at the moment. So if we have a look at our ordering service, again, the first thing we do is create an SQS queue, and that, as I've described already, is to just provide some element of rate limiting and back pressure in case there's a large influx of event that doesn't then overload our purchase order service. And then what we do is create an EventBridge rule, and an EventBridge rule allows you to specify a pattern that you can use to pattern match and only consume the events that you're actually interested in. And this is another really important difference between EventBridge and SNS. So when you use SNS, you can only filter the messages that your consumer receives based on the attributes of the message. You can't actually filter based on the contents, on the payload. Whereas with EventBridge, you can actually filter your events that you consume based on any of the properties within that event data. So you see here, I've created a pattern for the source being the product API and the detail type being product created. So they're the events that I am interested in that have come from the API and that they are created. So that's my EventBridge rule. You'll notice that the actual resource in Terraform is called a CloudWatch events rule. EventBridge used to be called CloudWatch events. That's the only reason that is there. We then set up a target for our EventBridge. So EventBridge works in two parts. You've got the rules, and then you've got targets. And the targets are where, when a rule is matched, that's where the event payload will be sent. In this instance, our event target is, of course, the SQS queue that we created at the top here. So we're specifying the name of our event bus to create the target on, the rule that we're going to use, which is the rule we created just above here. And then we've got our actual purchase ordering queue, and that's then going to push the EventBridge messages that have a source of product API and a detailed type of product created into our purchase order queue. Similarly to when we use SNS and SQS, we also have to set a policy on our queue that allows EventBridge to send messages. So you see we've got events.amazon.com, the service that's going to do this, for our queue, and for a source that is our rule that we've just created. So that again is quite important to remember, that you need to add that policy to your queue. If we have a look at our customer service, the code here is very similar. We create a queue, our pattern is the same, and then again we create that subscription and that policy. And we'll get on to actually doing the work off the back of these queues in a later video. So let's have a look at testing this now. So we've still got our same API that we had last time, and of course we've got some unit tests that we can use, integration tests, that we can use. So if I run a .NET test now on my product API, and I want to run my integration tests, and these are the same integration tests that we had in the last video, and remember, nothing at all has changed about our synchronous API. So this test will run in the exact same way it has. This code has not changed. So we've enabled publish subscribe in our application without changing a single line of the existing application code. If we now go off to the console, and if I first have a look in SQS, you can see I've now got some messages that have come through here. So I've got one message available in my customer service queue, one in my purchase order queue, and then you see the update product catalog queue that we created that was subscribed to our topic. That now has a message in flight. So that's now actually being processed. We have a look at DynamoDB now, and we have a look at our application integrations table, and we go to this exports and streams tab. If we have a look down at the bottom here, you can see we've got our DynamoDB stream that's enabled, and our trigger for this stream is the Lambda function that we created earlier. This is the stream handler. Remember, this is the function that's going to take that stream data and publish that to our SNS topic. If we take a look at SNS now, SNS, we've got our dev product created topic, and again, if we go in there, you see we've got two subscriptions to this topic, so it's really powerful in the console. You can actually see who's subscribing to what, and you see we've got our update product catalog queue and our external event publishing queue are the two subscribers for our product created topic. So if we have a look at EventBridge now, you see if we look at our application integration pattern samples bus, we've got two rules against this event bus, one for the customer service and one for the purchase order service. If I take a look at one of these now, we can have a look at the pattern that has been matched on, which in this case is our ProductCreated event from our product API. And we can also go and see the targets. We can go and have a look at what that rule is going to send things to. In this case, it is our purchase order queue. And we can also see some quite nice metrics in this same video that will show us the kind of rules that are flowing through this queue. And you see we've got one rule there that's been triggered. This rule's been triggered once, a few minutes ago. So that is publish subscribe on AWS with Terraform. And remember, we've done that in a way that has meant we've not changed our API code at all. We've kept the latency the same, the performance the same, the functionality, nothing has changed about our existing system. What we've done instead is enabled DynamoDB Streams, which allows us to stream data out of our DynamoDB table, which is in itself making our system more event-driven. Our function that's publishing to SNS is only doing work when something has changed. From there, we're publishing to SNS, and we're using SNS in this instance for our communication within our service. So we can imagine a place where we might have a product created, a product updated, and a product deleted topic. And within our product service, that subscriptions and the publish subscribe within our service is kind of coupled in a sense that we're coupled to a specific endpoint for a specific topic. We then, from there, are publishing data to Amazon EventBridge, and that publish subscribe works in the same way as SNS. We create an event and we publish it. The benefit with EventBridge is that our producers and consumers don't have any specific coupling at all. The API call to put events is a single API endpoint for a given event bridge, and then the consumers just add a rule to that bridge. They don't need to know where that specific topic, all they need to do is define the rules that they need to subscribe. That's all I've got today. That was publish subscribe. I will see you again in another week where we add some more additional functionality to this application using event-driven application integration patterns in Terraform. As always, if you've liked the videos, please share, please like, please subscribe below. All of this code is on GitHub. You can deploy all of this into your own account today. I will see you next time.